Hey everybody, Mr. Judson here. So I hope you guys all had a good Memorial Day weekend. It's kind of nice to get Friday and Monday in there and have a 4-day weekend and have a chance just to kick back and relax. I know for some people it was probably catch-up time. I did see the numbers and I saw that there's a few more views than last week. Last week I was a little scared. Some of the views were on videos were down pretty low. And let's just make sure we're plugging through till the end. I know it's sometimes from your guys' perspective it's a little hard to see why am I doing all this work, but we need to understand that this is going to pay off in the long run. Having a bunch of gaps in knowledge and feeling like you just don't have what you need to move forward is not a good feeling. And I think for a lot of people, huge decisions are being made through this process by kind of taking a step back and relaxing and not keeping up with things. That's going to affect what we're capable of doing in the future, especially when we move on to college and stuff like that. So there's going to be some repercussions. Those who have sat back and done nothing, wow, that's going to be tough. It's going to be a hard road to get yourself caught back up. Those who are staying on top of things, good for you. Good for you. That's important. Even when we're in a situation where we know that our grade is to a certain point, and me working hard isn't going to change that grade. Maybe for like someone has an A, or a B. Your grade can't drop. Well, working hard is going to make a difference in the future. We all have to be smart enough to realize that. So keep it up. Stick with it till the end. All right. Okay, so last week we talked about law of sines, which was a way for us to solve parts of a triangle when we don't have a right triangle. And so, one of the questions that comes up, if I have this triangle, ABC, okay, here's little a, little b, little c. One of the things I said with the law of sines is you must know an angle and its opposite side. Okay? So with law of sines, you must know an angle and its opposite side. We need to know that to use this rule. So the question now is, what if I don't have an angle and its opposite side? What if that doesn't happen? Let's say they gave us this angle and these two sides. There's no way to figure out this side so that I have an angle and the opposite side. All right? So we got to have another rule to use, and that rule is going to be the law of cosines. All right? There is no law of tangents. It's just law of sines, law of cosines. So if we don't know an angle and its opposite side, then we'll use the law of cosines. Now, last week I told you guys, or I showed you guys where the law of sines came from. This is a little more complicated. You could look it up on the internet if you want. Just type in, proof of the law of cosines, and you can find YouTube videos that would show it to you. But it takes some time to get through it. And when I'm trying to save memory on the video, it's a lot. So I'm just going to go ahead and write it down for today. Law of cosines is something that you would use when you know side, angle, side. Remember that from geometry? Ways to prove triangles congruent? So if I know a side, an angle, and a side, that angle has to be between the two sides. That's a time that I want to use law of cosines. Or if I know side, side, side. If I knew all three sides, that means I don't have an angle in the opposite side. That would be a good time to use law of cosines. By the way, if anyone's thinking this, well, if you know C and B, can't you figure out A with the Pythagorean theorem? The answer is no, because it's not a right triangle, right? If it was a right triangle, then yes, we could do that, but it's not. Okay, so we would have to use law of cosines. So here's what law of cosines says. It says that any side squared is equal to the other two sides squared. So that starts out looking like the Pythagorean theorem, but there's another piece to it. Minus twice these two sides times the cosine of the angle that's opposite this right here, angle A. And under normal conditions, I would say this is something we have to memorize, but the only test coming up is the Central Washington Final, which you're only taking it if you're trying to earn Central Washington credit. If you didn't go to that meeting last week, on Thursday, I think there were only 21 people there, and I know we've got somewhere in the neighborhood of 60 people trying to earn credit. That's 40 people who weren't there. There's a lot that you missed. And I'll be sending out a summary email of what we talked about. That's a meeting you really should have been at. So if you weren't, you might want to contact a friend and get some notes from them, because there was a lot of information. And it's now too late to drop that class. Last week on Friday was the deadline. And so those of us who did not drop the class, we're now committed to paying for it and taking that final. Okay? All right, so let's write down another one. There's three versions of the law of cosines. Okay? Any side squared equals the other two sides squared minus twice those two sides times the cosine of the angle that's opposite this side over here. So let's just say I wanted to start with side B. So B squared would equal the other two sides squared, so A squared plus C squared, minus twice those two sides, A times C, times the cosine of the angle opposite this one. Okay, you guys write down the third one. Go ahead and take a second, write that down real quick. All right, so any side squared equals the other two, so that's A squared plus B squared, minus twice those two sides, times the cosine of angle C. So this angle and this side are always on the ends, and they're opposite each other. All right? So there's the law of cosines, and that's what we want to use for today. So if you remember last week, I told you guys there is a slight problem with the law of sines. And the problem is it will never find an obtuse angle, an angle larger than 90 degrees. Okay? So if I'm looking at a triangle, if there's an obtuse angle, this won't find it. Okay? But this will. Because if you remember, when we did inverse trig functions, the inverse cosine always gives us angles in the first and second quadrant. So it will give us an angle from 0 to 180. And so kind of an important thing to remember is if they give you three sides to a triangle, the angle that you want to find first is always the largest one, which is opposite the largest side. So we'll do an example of that here in just a second. That way we get the largest angle out of the way right from the beginning, just in case it is larger than 90, and then law of sines is fine after that. Okay, so it's really important to remember, if there is an angle that's larger than 90, it has to be opposite the largest side, whichever one it is, and I want to find that first using law of cosines. I want to get that out of the way. So let's start with an example like that. All right, so here's a triangle where I know the three sides. I don't have an angle in the opposite side, and so I want to use law of sines. I just wrote down one of the three versions up here. Okay, so what I want to do is I want to find the largest angle first, which has to be opposite the largest side. So I'm going to try and find this angle to start this off. That way when I use law of sines later, because at that point I'll know an angle and its opposite side, I know law of sines will work for these two. Okay? Very important. Always find the largest angle first. So any side squared, so 5 squared equals the other two sides squared and added together, minus twice those two sides, times the cosine of the angle that's opposite 5, which is angle B. All right, so let's see, 25 equals 4 plus 16 minus 2 times 2 is 4 times 4 is 16 cosine of B. If I go ahead and add these together, I would get 25 equals 20 minus 16 cosine of B. Let's be careful of one thing right away here. I see this a lot. People look at this and they go, well, 4 plus 16 minus 16, let's see, those add up to 0, so I just get 4 cosine B. And the problem with that is we're not following the order of operations. You have to do multiplication before adding and subtracting. It's okay to add these two together because they're not being multiplied by anything. But I cannot subtract these two because that 16 is being multiplied. And if I do the subtraction, I'm doing subtraction before multiplication. Okay, I don't want to make that mistake. Our standard procedure is add these together and then move it over and subtract it. Okay, I got to get this by itself, so now I'm going to get rid of one thing at a time. So move the 20 over and subtract it. You've got 5 equals a negative 16 cosine B. To get that cosine B by itself, I'm going to divide by negative 16. So I've got a negative 5/16 equals cosine B. And now I just need to do the inverse cosine of this on the calculator. And you know, if you write it down as a decimal, that's fine. Our calculator doesn't care if it's a fraction or a decimal. So I'd probably just leave it like that. So on my calculator, I've got inverse cosine of a negative 5 divided by 16. So remember, cosine is negative in the second quadrant. So I already know I'm getting an angle larger than 90 here for this one. All right? There it is, 108.210 degrees. So 108.210 degrees. And again, if the book asks us to change this to degrees, minutes, and seconds, that's fine. We just use our DMS option. So angle B is equal to 108.210 degrees. So now at this point, I know an angle and its opposite side, so I could go to law of sines. Now, if you want to, you can do law of cosines again, but in general, most people feel like law of cosines is a little more work than law of sines. So if I go to law of sines, I would have the sine of 108.210 over 5 is equal to, let's just do sine of A over 4. So to get sine of A by itself, I'll go ahead and move this 4 to the other side and multiply. We're dividing here, so opposite of that is to multiply. So now I've got 4 sine of my last answer divided by 5. And so I got 0.760 equals sine of A. So now I'll just do inverse sine of that. So second sine of the last answer. And I got angle A equals 49.458 degrees. And so the last step here is to find angle C. So this was 49.458. So now I just have to add those two together and subtract from 180. So I'll just go, let's see, angle C is equal to 180 minus angle B minus angle A. So 180 minus, go up and select the 108.210 minus, I'll go up and select 49.458. And what I got for angle C is 22.332. Let's see if I write it in my picture, 22.332 degrees. You know, if you went back and added all these together to see if they add up to 180, you know, of course they will because of what we just did. But again, I just kind of want to look at this and go, all right, smallest angle is opposite the smallest side, largest angle opposite the side. I kind of expected these to be a little bit closer together, but I guess not. That's not a guarantee that should happen. If you look at these two sides, they add up to 6, which is just a little bit more than this side. So in reality, you know, this triangle probably looks more like this. That's not a very good picture of what that triangle really looks like. So yeah, this angle should look really large. This angle should look quite a bit smaller than that. All right, we have solved that triangle. Let's try another one. All right, you guys go ahead and try this one. So this triangle looks a little different. This side is 6, this side is 13, and that's 40 degrees. And we want to solve the triangle. So again, that just means find all the missing parts. You guys go ahead and try it. All right, so I don't have an angle in the opposite side, so I have to use law of cosines. And so the side that probably makes the most sense to find first is the side that's opposite this angle. Okay, little b. So I'm going to say little b squared equals the other two sides squared and added together. So 6 squared plus 13 squared minus twice those two sides times the cosine of 40. So when you look at this, I've got nothing but numbers over here. This is the best possible situation for us, because that means all I got to do is figure out what all this is equal to and then just take the square root to see what b is. So that there's not a lot of work. It's just making sure we get things written down properly. So I'm just going to grab my calculator. And I'm going to go 6 squared. If anybody's hitting 6 squared on your calculator, shame on you. We know what 6 times 6 is, right? So when you see that, just go ahead and punch it in there. 36 plus, if you're not so sure about that, then yeah, go ahead and do 13 squared. But I believe that's 169 minus 12 times 13 times the cosine of 40 degrees. And so what I got is 85.497. So b squared equals 85.497. Now I just have to take the square root. So square root of last answer. And I got b equals 9.246. You know, I just realized I haven't checked to see if I'm in degree mode. Luckily I am, so I haven't messed anything up yet. But always check that. Always go back and see what mode you're in. All right, so this is now 9.246. Since I now know an angle in its opposite side, I could now use law of sines to find the next piece of information. However, this is important. I don't ever want to use law of sines to find the largest angle. And where is that largest angle here? It's angle A, right? Because it's opposite the largest side. 13 is larger than 9 point something, which is larger than 6. So I don't want to find this angle next. I want to find this angle over here. Then I'll add those two together and subtract from 180 to see what's left. Okay? I never want to use law of sines to find the largest angle if I can help that. All right, so I'm going to say that the sine of angle C over 6 is equal to sine of 40 degrees over 9.246. And so to get sine of C by itself, I'm going to move this 6 to the other side and multiply. And so now I'll grab my calculator and I'm going to do 6 sine of 40 divided by my last answer. And what I got is sine of C is equal to 0.417. Remember, this number always has to be somewhere between 0 and 1. Positive or negative, but it's got to be somewhere between 0 and 1. Okay? And now I can do inverse sine of that last answer. And I got angle C equals 24.652 degrees. And so now to find angle A, that equals 180 minus 40 degrees minus angle C. So 180 minus 40, I can't believe I just did that on the calculator, minus what I had for angle C. And so I got angle A equals 115.348. There's my 3 pieces of missing information. Make sure you always show this step. You know, show the work for it. There's not a lot to write down. And even though I know you guys know what you're doing in your head, you know, we want to communicate on paper what we're doing. You know, and you know, again, we're not turning anything in, but just to keep good habits going here, you know, we want to do that. All right, let's try one more. All right, you guys go ahead and try this one. So if anybody looks at this and goes, oh, come on, Judson, that's easy. 90 degrees, and I can just say cosine equals adjacent over hypotenuse. Be careful. This is not a right triangle. I drew a really bad picture. If it was a right triangle, the 5 would have to be here, right? This triangle probably looks a little bit more like this in reality. Okay, so this is not a good picture. I guess I do need to label the angles. So if you labeled yours differently, that's okay, but we just got to figure out what those are. All right, so I want to find the largest angle first using law of cosines. That's got to be opposite the 5, so I want to find angle B. So I'm going to say any side squared equals the other 2 sides squared and added together minus twice those 2 sides times the cosine of the opposite angle, which is B. All right, so 25. You know, here you can look at this and go, this is 9 plus 16, 25, minus 6 times 4, that's 24, cosine of B. Can't do the subtraction. Multiplication has to take place first. So now we have to start solving for angle B. So I'll move this over and subtract it, and I get 0. And then I divide by negative 24, so that would still be 0. Which by now, you know, probably some people are scratching their head going, wait a minute, how does that happen? So I do inverse cosine of 0 on the calculator, and what I get is angle B equals 90 degrees. And we might look at that and go, well, wait a second, Judson, I thought you just said it wasn't a right triangle. Yeah, this can't be the right angle, the way the picture's drawn. Could this up here be the right angle? Well, yeah, because it's a 3, 4, 5, so that makes sense. So this is 90 degrees. So if that kind of messed with your head a little bit, that's okay. It messed with mine a little bit too. I had to pause and think about that. But that's what it is. Okay, so now I know that this angle's 90. So now I can go ahead and do law of sines. Let's find angle A next. I'm going to say sine of angle A over 4 is equal to sine of 90 over 5. We'll move that 4 to the other side and multiply. And so now in the calculator I've got 4 sine 90 divided by 5. I can't believe I just did sine 90 because if you think about the unit circle, at 90 degrees it's the y-coordinate, it's just 1. So really this should equal 4/5, right? Which is the same as 0.8. So sine of angle A equals 0.8. I'll now do the inverse sine of that. So second sine of 0.8. And I got 53.130 degrees. Alright, so one angle left. I just need to subtract these two from 180. Or, since I've used up 90, I know there's only 90 degrees left, I could just subtract that from 90. So 90 minus my last answer. So angle C equals 90 minus angle A, which is 36.870. There we go. We have solved that triangle. All right, so that's it. That's what we have for today is using law of cosines along with law of sines. And the only reason we're using law of sines is because it's less work and easier, right? So we still want to keep that as an option. Tomorrow, what we'll do is we'll start looking at some story problems using this. I don't know if you guys remember if a ship leaves the east coast and heads with a bearing of north 32 degrees east. Yeah, we're going to take a look at those. The nice thing is law of cosines and law of sines makes those problems a little bit easier. So we just want to go back and revisit that idea and apply this rule to it. All right, let me get you guys an assignment. Also one more thing. For those doing the Central Washington class for credit, I believe I said our final exam will be on June 14th. That was a mistake. That's a Sunday. June 16th is a Tuesday. That's the day that we'll take that final exam. All right, so here's number C18, page 443. We're going to do 2 to 4, 8, 9, and 11. And then 29 to 31, these are actually story problems, but they're really not anything more than just drawing a triangle, putting in some numbers, and doing what we did just now. So you should be fine with those. All right, there it is. See you guys tomorrow. We only have 2 days this week, Wednesday and Thursday. So have a good day, stay safe.